Okay, if you're a developer, you know this feeling. Your mobile app is making some kind of API call, it's failing, and you have absolutely no idea why. There's no error message, no log, just nothing. The network traffic is a complete ghost, and you're totally stuck. Well, today, we're going to fix that.
So why is this even a problem? I mean, why can't you just see what your own app is doing? It's a super common frustration. See, unlike web development, where you've got all these amazing tools built right into the browser, mobile can feel like you're trying to debug something inside a locked box. So how do you get a look under the hood?
Right. For any web app, you just pop open the browser's DevTools, and boom, you have a full-on command center to inspect every single request and response. It's awesome. But for a native mobile app, that network traffic is a total black box. You tap a button, something breaks, and you're left completely guessing. Well, it's about time we found a key for that box.
And that key, my friends, is Charles Proxy. Seriously, think of it like getting X-ray vision for your app's network layer. It's a tool that lets you see literally everything happening between your app and the internet. It finally gives you the visibility you've been desperate for.
So how in the world does this work? Well, Charles acts as what's called a man in the middle. It wedges itself right between your device and the internet. By routing all of your app's traffic through your computer, it can capture, inspect, and get this, even modify every single request and response. It becomes the ultimate gatekeeper for all your app's data.
And you'd think something this powerful would be a huge pain to set up, but nope, it's actually a super fast two-step process. First, you just go into your phone's Wi-Fi settings and tell it to send all its traffic to your computer's IP address on port 8888. That's where Charles is listening. Second, you open your phone's browser, go to the special URL chls.pro/ssl and install the Charles certificate. This second step is absolutely crucial because that's what lets Charles decrypt all the secure traffic.
And just like that, the magic begins. Once that certificate is installed and trusted, all that encryption that normally hides everything, it's unlocked just for you. You can now see the contents of all your secure API calls in plain, readable text. It's amazing. All right, once you're set up, this is where you're going to live. As traffic starts flowing in from your app, you can click on any single request to see everything about it. You can check the headers to make sure your auth tokens are correct. You can look at the request payload to see the exact data your app is trying to send. You can inspect the raw response body coming back from the server. And best of all, you get a crystal clear view of the HTTP status code, so you know instantly if a call worked, failed, or did something weird like redirect.
Now, being able to see the traffic is a total game changer, for sure. But that is only half the story. The real power of Charles comes when you realize you don't just have to watch, you can actually get in there and manipulate the traffic in real time. This is where you go from just debugging to some serious power testing.
Let's start with breakpoints. This is so cool. This feature lets you literally pause a network request or a response while it's in the air. So imagine your app is about to send some data. With a breakpoint, Charles stops it, lets you edit the payload to test some weird edge case, and then sends it on its way. You can test how your backend handles bizarre data without ever touching your app's code.
Now, if breakpoints are for those one-off manual tests, rewrite rules are all about automation. You can set up rules that just automatically change traffic as it passes through. For instance, you could make a rule that turns every successful 200 OK response into a 500 internal server error, just to see if your app's error screen looks right. Or you could automatically strip out an authentication header to see if your app gracefully handles an expired session. It's so powerful for tests you need to run over and over again.
And this one? Oh, this is how you finally track down those impossible bugs. You know, the ones that only seem to happen for that one user who has a terrible connection? The throttling tool lets you simulate slow networks by dialing down the bandwidth and cranking up the latency. If a user complains your app is laggy on a 3G connection, you can now feel exactly what they're feeling and find the bottleneck.
Okay, let's put this all together. We're going to walk through a classic real-world support ticket, one of those phantom bugs that gives the developer zero information to go on. So here's the report from the user. My payment fails, but the app doesn't tell me why. It just fails. As a developer, this is the worst. You have no clue where to even start. Is it their input? Is it a server issue? Is it a bug in the UI? You're just lost.
But with Charles running in the background, we just ask the user to do it one more time, and boom, the answer appears in seconds. The network log shows that when the app sends the payment confirmation, the server isn't sending back a success or a failure code, it's sending back a 302 redirect. And our app's code, it was never built to handle a redirect at this point, so it just fails silently. Mystery solved.
And that right there is the difference. Before Charles, we had a mysterious bug with 0 clues. After running Charles for less than a minute, we have the exact root cause, an unexpected 302 redirect that our app just wasn't handling. The bug went from an impossible puzzle to completely obvious in the span of a single network request.
This is the power you get when you can make the invisible visible. It turns debugging from pure guesswork into a science. So really, the only question left is, once you get these X-ray specs for your own apps, what's the first phantom bug you're going to go hunt down?